Good morning, students. Now our 3.2 is over. Okay, so today I am going to start your next theorem, that is isosceles triangle theorem. Before that, what we learn? We learn the exterior angle theorem is and the properties of triangle. On that basis, we solve the examples. Now I am going to explain you the all of you know that the what is isosceles triangle. The triangle which having two sides are equal. Is it called as a isosceles triangle? Now, what is the theorem? And theorem means what? How we have to prove. What we have to prove? If two sides of a triangle are congruent, then the angle opposite to them are congruent. We have to prove that if two sides of a triangle are congruent, that's why the theorem name is isosceles. If two sides of a triangle are congruent, then the angle opposite to them are congruent. Okay. So what is given here? It is given that this triangle ABC is a isosceles triangle in such that AB is equal to AC. Any two sides of a triangle are congruent. What we have to prove? We have to prove that the side angle opposite to the congruent side. Which two angles are there? B and C. Meet angle ABC and angle ACB. They are congruent. We have to prove. Draw the bisector of angle BAC which intersect the side BC at point D. Draw the bisector. Angle bisector, all of you know that. It divides the angle in two equal parts. So draw the angle bisector of BAC. It divides two angle equal part means BAD is equal to CAD. Now, this is our construction part. That's why I am showing here. It is always showing here by a dotted line. Always remember the construction part show by the dotted line. It will easily recognize. Now, what is the proof? In triangle ABC, after drawing the bisector, two triangles are formed. Triangle ABD and triangle ACD. Now, in triangle ABD and ACD, AB is equal to AC. This is given. AD is equal to AD, common. And angle BAD is equal to angle CAD because of the construction. And therefore, triangle ABD is congruent with triangle ACD by SAS test. Now, we proved these two triangles form, they are congruent. It means that their corresponding angles and remaining sides also congruent, and therefore angle ABC is congruent with angle ACB. Understood? So if all the sides of a triangle, now this is a corollary, you have to write the proof. If all the sides of a triangle are congruent, then all angles are congruent. Now proof. You have to prove. This is your homework. Okay, try to prove. It's very simple. Take one triangle as a equilateral triangle because all sides are equal. So we have to prove all angles are equal. Now we have to take like this same only. Again you have to take this B is equal to C. Now by taking a B angle bisector, A is equal to C. Now first is what? B is equal to C. Second is what? A is equal to C. And therefore ABC are equal. Means this is the first part, and the second part by taking the angle bisector of B. Then we have to prove A is equal to C. Now see here, B is equal to C, A is equal to C. It means that A is equal to B is equal to C. Okay, in this way you have to prove. Now the next theorem is a converse of isosceles triangle theorem. If two angles of a triangles are congruent, then the side opposite to them are congruent. Now listen, this is a triangle in such a way that angle Q is equal to angle R. Same construction. What we have to prove A PQ is equal to PR. Very simple. Now just use the angle, draw the angle, construct the angle bisector of angle QPR. Is it? So after drawing the construction of angle bisector of angle QPR, these two angles are formed, angle PQM and angle PRM. Okay. Now angle PQM is equal to angle PRM. This is a given. Because of angle bisector, angle QPM is equal to angle PRM and PQM is equal to PRM. One is given, one is by the construction. Now segment PM is a common in between them. Therefore by AS test, these two triangles are congruent and therefore their corresponding sides are congruent. That is PQ is equal to PR. Finish. Now the next theorem, if the acute angle of a right angle triangle are measure of 30 degree, 60 degree, then or 90 degree, then the length of side opposite to 30 is half and length of side opposite to 60 is a root 3 by 2. Firstly, we will prove that the side opposite to 30 degree is half of the hypotenuse. Okay, we proved this theorem is proved and then we are using a property. As a property we are using and we are solving the examples. Now in triangle ABC, angle B is equal to 90 degree, angle C is equal to 30 degree, angle A is equal to 60 degree. So what we have to prove? AB, side opposite to 30. Which side it is opposite to 30? AB. So AB is half of AC. Now construct, take a point D in such a way that AB is equal to BD and join CD. Okay. Now what we have to took here, AB is equal to BD. Now if you are observing this diagram, triangle ABC and triangle DBC, these two triangles are formed. AB is equal to BD by the construction. Angle ABC is equal to angle DBC by the 90 degree. BC is equal to BC, this is a common, and therefore these two triangles are congruent by SAS test, and therefore angle BAC is equal to angle BDC by the corresponding angle of congruent triangle, and therefore this angle is 60, this angle is 60. Now this is 30, this means is also 30. So angle in triangle ADC, this is 60, this is 60 and this is 60. If all the angles are 60, then this is equilateral triangle, is it? And if it is equilateral triangle, if AB is equal to BD, then B is a midpoint of AD. It means that AC is equal to AD is equal to BDC. So, but AD is equal to half of the AB. AB is half of AD. AB is equal to half of AD, and therefore what is AD? AD is equal to DC over AC, and therefore AB is equal to half of AC. Finish. Hence we proved. Understood, students? Very simple theorem. Yes, just if we know the concept, definitely we can prove. Now the activity. With the help of figure 3.29, which one? This one. Okay, we have to prove that the side opposite to 60 is root 3 by 2. Now all of you know that in the theorem what we proved? We proved that AB is half of AC. So AB square, according to the Pythagoras theorem, AC square is equal to AB square plus a BC square. But AC is half of AB. So substitute AC is equal to half of AB. Okay, so AB is equal to half of AC. So instead of AB we can write 1 by 2 AC square plus a BC square is equal to AC square. 1 by 2 square means 1 by 4 AC square plus BC square plus is equal to AC square. Now we have to shift this two side. BC is as it is, AC square minus of 1 by 4 of AC square. So 1 minus 1 by 4 is 3 by 4 of AC square. By taking a square root, you will get BC is equal to root 3 by 2 AC. So students, up to this, all the theorems you have to write in your notebook and try. This is only one homework today I am giving you. This, write the proof of this corollary. Okay students, do study regularly, and this all the theorems in your textbook is there. Whatever the blanks are there, I already fill. So tally your answer and complete this activity. Okay.